All right, let's dive in. Today, we're going on a bit of a quest, a journey right into the heart of modern cryptography. We're trying to solve a problem that, honestly, could affect everything you own online one day. We're going to figure out how to build an app where your access can never, ever be lost. Just imagine this for a second. You've got your most important digital stuff locked up and encrypted, your will, family photos, maybe your life's work. And then the company that made the software you used just goes out of business. Their website disappears, poof, and just like that, you are locked out, permanently. Your key is useless. Your files are basically gone forever. And this isn't some sci-fi plot. It's a very, very real risk we're all facing. Now, the hero of our story is supposed to be the passkey, and it's an amazing piece of tech, right? It promises this future with no passwords. You just use your face, your fingerprint, and boom, you're in. It's simple, it's super secure, and it's rolling out everywhere. But this hero has a hidden and potentially fatal flaw. Okay, let's get into the weeds here. To really get what's going on, we have to look at both sides of the coin, the incredible promise of passkeys and the hidden danger that comes with how they actually work under the hood. This right here, this is the absolute core of the issue. You see, every single passkey is born with this kind of digital birth certificate. It ties it to one and only one website domain. The technical term is the relying party ID, or RPID. Think of it like a key that's been permanently welded to a single lock. Your passkey for yourbank.com will only ever work on yourbank.com. It's a fantastic security feature, but it's also a trap. So let's see how this plays out in the real world. Say you create a passkey for an app online at FileKey.app. That key is now cryptographically handcuffed to the RPID FileKey.app. But what if you download that same app and run it on your own computer, what we call localhost, and make a new passkey there? Well, that key gets locked to the RPID localhost. And here's the crucial part. These two keys are not interchangeable. They're complete strangers to each other, even though they're for the exact same app. And that, right there, leads us to the terrifying question at the heart of our entire quest. If your key is permanently locked to a domain, and that domain just vanishes from the internet, well, your key is now just a useless piece of data. You're blocked out. And not for a little while. Forever. So this problem sent developers on a real journey, a search through this maze of new, cutting-edge, decentralized tech. The goal? Find a single permanent domain, a digital address that could never, ever disappear. The plan seemed logical, right? First, you put the app's code on something like IPFS, the Interplanetary File System, so no one can just take it down. Second, you give it a decentralized name, like an ENS domain, so it can't be seized. Third, you use a gateway service so normal web browsers can actually find it. It seemed like the perfect plan. Until they hit a massive, unmovable wall. And here's exactly why the whole thing just fell apart. The browser's security model is, well, it's brutally simple and incredibly strict. It just asks two questions. One, what website domain are you visiting right now? And two, it asks the passkey, what domain were you created for? If those two strings of text don't match perfectly, access denied. End of story. No exceptions. All those clever decentralized tricks still needed a gateway domain, and if that gateway isn't the exact RPID your passkey is locked to, the browser just slams the door in your face. So the quest hit a dead end. The very thing that makes passkeys so strong, that rigid, unbreakable bond to a single domain, is also what makes them so fragile. It really seemed like true permanence, true ownership was just impossible. But this is where the story gets really interesting. You know, when you hit a wall like that, you have to stop and rethink everything. And that's what happened. They had to pivot from finding one perfect key to a completely different strategy. And this was the breakthrough, the big aha moment that changed everything. The original quest was flawed from the start. Maybe the goal shouldn't be to find one single, invincible domain that can never, ever fail. Maybe the goal should be to make the system so resilient that it just doesn't matter if one domain fails. So the old quest, on the left, was all about finding a single point of success. It's a really brittle strategy when you think about it. The new idea, on the right, is all about creating redundancy. It's about building a system with so many independent ways in that a single point of failure just becomes irrelevant. And this is the specific little piece of tech that makes the new idea actually possible. It's called a progressive web app, or PWA. It's a special kind of web app that you can install on your computer or phone. Now, once it's installed, it can run completely offline. And this is the crucial part. It can create a passkey that is locked to the RPID localhost. This key doesn't depend on a company or a server or even an internet connection. It is a truly permanent key that you, the user, control forever. So, with this new philosophy and this new tool in hand, the team was able to design a truly elegant solution. It's one that combines the convenience of being online with the rock-solid permanence of offline control. And you know what's really cool? They didn't need any complex experimental crypto to pull this off. The answer was a well-known, battle-tested technique. It's actually the same way secure group chats work. You don't send 10 separate encrypted messages to 10 people. No, you encrypt the message once, and then you create 10 little key packages, one for each person, that can unlock that single message. So here's how it all works in practice, and it's just beautiful in its simplicity. When you go to encrypt a file, the app first creates a new, totally random key. We'll just call it the FileKey. It uses that key to lock up your data. Then, instead of just storing that FileKey, it encrypts the FileKey itself, over and over, using your different passkeys. Once for the main website, once for your offline PWA, and hey, maybe even once for a hardware key, like a YubiKey if you've got one. The final result is this single file that has two parts. You've got one big blob of your encrypted data, and then attached to it is this small chunk of metadata. And inside that metadata are all those little key packages, or what we call wrapped file keys. Each one of them is a potential doorway back to your data. And here is the magic of the whole system. To decrypt your file, you don't need all the keys. You don't even need a majority of the keys. You only need one. Any single one of your passkeys is enough to unwrap that file key, which then unlocks all your data. So that's a lot of technical wizardry, I know. But what does all of this actually mean for us, for real people? Well, it means we can start building systems based on a completely different set of principles, leading to a much more resilient and user-focused internet. This whole solution really embodies a powerful design philosophy. Instead of chasing this impossible goal of invincibility, it embraces redundancy. It puts user sovereignty, that's your control over your own data, first and foremost. By its very design, it eliminates any single point of failure. And it gives you the absolute best of both worlds, the easy, everyday convenience of an online service, combined with the ironclad permanence of an offline tool that you control. This is the ultimate promise. This is the holy grail that this whole quest was about. With this model, you can confidently look your users in the eye and tell them that even if your servers get wiped off the face of the earth, even if your company goes bankrupt and your domain name is bought by someone else, they will always be able to access their data. And that leaves us with one final, pretty big thought. For decades, our ownership of digital things has been incredibly fragile, right? It's all been dependent on the companies that provide the services. But if we can build systems where our access, our keys, can never be lost or taken away, what does that mean for the future of property, of identity, and what it truly means to own something in our digital age?